Lesson 3-4, Model Linear Relationships. Remember, we can model linear relationships by using an equation. A model can be written as an equation, y equal mx plus b, or later you'll see f of x equal mx plus b, and y and f of x mean the same thing. F of x means the function of x, which is what y is. Example 1, write an equation to represent the linear function from the table. So we are modeling this linear function. We need to have two things to write an equation. We need to find the slope m, or rate of change, and the y-intercept b, which is also called the initial value. From the table, we can easily find slope. Remember, we can quickly find slope from a table by looking at the change of the y's divided by the change of the x's. And it really doesn't matter what two ordered pairs you use. So I'm going to take these first two. I'm going to say the y's go up 5, and then the x goes up 10. And so 5 over 10, we can leave that as a fraction 1/2, which I'm going to do. Or you could have changed it to a decimal, 0.5. And it really didn't matter which two ordered pairs you chose. You could have done these last two ordered pairs. The y went up 5, the x's went up by 10, and you'd have gotten the same thing. So we've got the slope. Now we have a couple different ways we could find b, the y-intercept. I'm going to show you one that never fails. If you can't just look at it in the table and find the y-intercept where x is 0, then remember you can find it by using y equal mx plus b. You already know m is 1/2. You're going to choose an ordered pair. I'm going to choose 30, 20. But I could pick any one of those 4 ordered pairs from the table and label it x and y. And then I just plug it into the equation and solve for b. Y is 20 equals m is 1/2 times x is 30 plus b. 1/2 times 30 is 15. Subtract 15 from both sides to get b by itself, and b is 5. You could have found b by using a table. So I'm going to note that. Or find a pattern in the table where, remember, a y-intercept is where x equals 0. So if I were to extend this table the other direction at the top of it, notice that I could say, well, when x was 0, y must have been 5. I just extended my table. Sometimes I can do that. I can find a pattern where x is 0, y is 5, so I could get b is 5 from that as well. In either case, we get our equation, y equal mx plus b, and in this case, m is 1/2, and b is 5. Example 2, write an equation to represent a total cost C of renting a kayak for T hours. Notice that in this problem you're given a graph. We still need to find the same pieces of information. We need the slope m and the y-intercept, which is the b, which we also call an initial value. So we can look at this graph, and we might zoom in just a little bit here. And we're going to find the y-intercept. That's the point that it crosses the y-axis. It crosses here halfway between 6 and 7. So b, the y-intercept, is 7. Now to find slope, we can use rise over run. I'm going to pick 2 points. I've already got the y-intercept, and I'll pick one more. And so I'll say rise over run. It goes up 3 units from 7 to 10. Then it goes right it looks like 1 unit, but if you notice at the bottom that it's every 2 blocks are counting 1 at a time, so it goes right 1 to get 3. So m, the slope is 3. Now, we would normally write this equation in y equal mx plus b. So we'd have y equal 3x plus 7. But notice that it gives you different variables instead of x and y. It gives you that c is the y value, the total cost. So we're going to replace y with c. And x is the time in hours, and it's labeled on the x-axis as t. So we're going to replace x with t. And now we've written this equation representing the total cost of running a kayak for t hours.